Tell me when it goes live. It says I'm live. Can everyone hear me and see me now? Let's see. I'm gonna. You see me now? All right. I have confirmation from one individual. Can you guys hear me? There is a lag. So if you're in the chat right now, so we're gonna do a test. I'm communicating with someone on the phone right now, and they're helping me out. Anyone in the chat right now? Here we're gonna do so when you see me, I'm watching it live too now. When you see me snap my fingers, tell me when you see me snap them, okay? Here, they're already joining the Kahoot. All right, it looks like a 5-second delay. So, there we go. I see some people. Well, I think we got this figured out. I'm going to start, I don't know, if you want to watch, yeah, feel free to watch or play along. It's like we got a 5-second delay. Well, thank you very much for your help. Are you going to watch or play along?
I won't play along.
Okay, well, tell me what you think of the review. Bye. Hey everyone! Okay, so looks like we got people joining in. You can see the instructions. I'm watching it with you guys too right now. There's a little bit of a delay. It looks like you guys can hear me and see me. Talk to me in the... Whoa, we got some spam bots going right here. What is going on? What is going on with spam bots? What just happened to us? Is somebody like using a spam program to do us like that? No, we don't want that, guys. I might need to reset the Kahoot. There are no prizes for this Kahoot. There are no prizes. How are you guys doing in the chat? Talk to me in the chat right now if you can talk to me in the chat. Oh, spam bot or something. My only... Hello. So, hey, it's a pirate. I like pirates. So we're on a little bit of delay, and the audio is good quality, everyone. How is everybody doing? We'll see if we get more people to join in. Man, I have no idea. Hopefully we don't have another mass. Do not use spam bots or else you could crash this Kahoot. There's no prizes for winning. What's up, Davis? Don't fail the exam. No one fail the exam. I'm here. I can read the chat as we're playing along. So so if you are logging in right now, so this is my instruction to everybody trying to log in. I can see all your questions, and if you have one, what you'll do is you'll go to kahoot.it. You'll go to kahoot.it. It says at the top, go to kahoot.it. And on kahoot.it, you'll simply type in this pin. 9. No, we can't have more of these spam bots. You're gonna... Or did we lose the spam bots? I think it purged the spam bot. And, yes. So don't... Who's ever doing that, don't do that, because we could run into problems. We don't want that. Yes. Ventesto, please don't do that to us. So hopefully this all works. So, Steven, did you figure it out? Oh my gosh, what's happening? Okay, I think it's purging that spam bot. It seems to be smart. So it's very interesting watching this go on. I will help everybody to the best of my abilities. Is it kicking anyone out? How's it doing with everyone joining the Kahoot? I think it's just purging the spam bot. It looks like we're doing all right. This is the first time I've ever done a review like this. So it looks like we're okay. Communicate, still in Kahoot. So is it working? We're working good. Got 100+ players. We're going to wait for about another 5 minutes to start it up. So make sure, do not spam bot us, please, whatever you do. There is no points for this. There's no points. Oh, no. What are you supposed to do? Go to kahoot.it and enter in the pin. And if you guys want, hit that like on the video. No. Don't spam bot us, Love Trump. Don't. I think it'll purge that person. But who's ever using spam bots, I've heard of this before. And thank you for the people helping out in the chat. I think it'll start to purge that person eventually. But no. The reason is, if you spam bot us, you could crash the whole Kahoot. because the more people are in Kahoot, the more bandwidth it takes. Also, I'm streaming right now, so the streaming service could, going through YouTube streaming and running Kahoot could cause some bandwidth issues. So please do not spam bot us, or this might not work. But we're gonna wait till about 8:05, and if you pay $100, give me an A. Costs a lot more than 100, and plus, I don't know. That's a joke. It would cost like $100 million. You could donate $100 million to the UT, and then they'll maybe think it over. Let UT decide that. There's no amount of price you can pay. But no, we do not accept money for grades. No, there's no bidding on grades. But no. I did have a student one time, very quick story, come up to me and say, "I'll give you $20 if you can get me in your class." And I was like, "That's not how these things work. That's not how school works. You don't join a class for money. I do not take money for grades. I do not take money for grades or to join." What's the real pin? 988453. Please do not spam us with it's 988453. Is everyone doing all right? We'll go for another 4 minutes here before we start it up. We got 199 watching. If you want, I'm going to be like classic YouTuber here, like and subscribe to the channel, and then you can unsubscribe when you leave UT, or if you want after this, or you don't need to subscribe or anything. But we try to make some helpful videos for you guys, whatever you want. Always feel free to contact me. My email is bs@utk.edu. Pirates helping out with the pin. I like it right there. The real pin is 988453. There we go. Some chat going on. We're going to go for about another 4 minutes here. Oh, please do not spam us, who's ever doing this spam bot thing. It'll purge it again. I might have to wait till we get another purge on this spam bot. Please do not do that to us, or my computer is going to go crazy. And I might have to watch the power on my computer, because it's definitely acting up. It's definitely saying you are using some of the processor right now. Will I give you some of the inside info on the exam? I definitely will do my best to help you out with the topics of what we are learning. We got a lot of people logging in right now, and so the point of this Kahoot. Keep asking those questions if you got them. But the point is, we're going to go over some of the major topics you need to know for the exam. And we're going to talk about the concepts behind them. So there might be, in between each question, I'm going to try to explain it. And you guys can ask questions. This should last about an hour, hour and a half. And I have a full charge on my battery. And I'm at 67%. I'll be right back in one moment here. If people want to say, Brian's going to get his charger, because it looks like this is going to use a good bit of my battery. So I'll be right back, everyone. So just one moment. I see someone saying play Fortnite, and maybe we'll do that afterwards. I don't even have Fortnite, so I can't even do this. So we are back, and I have a charger on. Does it look like we need to wait for it to purge down? Because I don't think we have 439 players. This is not pre-recorded. This is live, Daniel Kim. We are live right now. This should... so we're going to wait a few more minutes here. It looks like it's purging a little bit. Do Fortnite quiz. Oh, man. Can we rewatch this? We should be able to rewatch it. It should post to YouTube. As long as nothing blows up. As long as nothing goes crazy. Rick Grimes, KD. Rick Grimes, this kill-death ratio is. How's everyone doing with getting into Kahoot? Looks like we have people joining in. We're going to wait. As long as people are joining up, we have 240 watching now. That's a really great number. Well, thank you, Daniel. So you guys can unsubscribe when you leave a T, or you never need to subscribe. But I upload new videos, especially for the test. So thank you, Dylan, for helping out with the key to the join up. But I try to, make some videos when you guys need them. And looks like we're doing all right. We're going to wait 2 more minutes because we still had a few more people join in. So we'll wait 2 more minutes. It's quite possible that we have people playing with their friends. Maybe, 2 people in a room, 3 people, 4 people. So you never know. How's it? I got botted. Yeah. So how do people, what's up with these bots? Does anyone have any idea how these bots join in? Yeah, how's that happening? Why do bots do Kahoot? I've never even had this issue before when I've done it in class. Oh no, I'm sorry, Based God. We'll try to catch the issues next time. I hope 87's good, but we'll try to find out where the things are. No, don't Vintesto. Don't add bots, Vintesto. We don't want this to crash. So let's see here. Let's report this user. And Vintesto, don't do that to us. This is my first time running a live event, guys. We'll get this. Okay. I tell you what, who are some of my 201ers? I'm going to add you guys as mods for the channel. We'll start up here in just 2 minutes. Who's some of I saw a few people. It's whatever your name is, it's not appreciated, so I'm not going to take the time to say your name correctly. So, let's see here. Who else is, yeah. Let's see. I do not, unless I know your name pretty well. Like, I have to know exactly who you are pretty well. I think, yeah, let's go ahead and get started here. Wait. We're going to wait for it to purge down to about 200, and then we're going to hit start as soon as... Sorry, we have one person in here trying to cause shenanigans. But I'm so sorry, guys, about the shenanigans. That is beyond my control. There's no points for winning the Kahoot. Yes, let's get a pirate's help. That would be excellent. Sometimes you know who a person is, so if they want to do whatever they can to Vintesto, or they have the power now. We're going to wait for this to purge down to about 200, then I'm going to hit start. So, very sorry, guys. What questions are there? Oh, look at that. There's a lag, and I've got it. Okay. So you guys should be seeing the questions now. Sorry, there's a little bit of a delay. But to multiply the probability of A and B, the 2 events must be what of each other? To multiply the probability of A and B, the 2 events must be what of each other? Independent, dependent, mutually exclusive, or disjoint. And I'll answer all these questions and we'll talk about it afterwards. But to multiply the probability of A and B, the 2 events, so this is when you multiply A and B, you put a multiply sign between them. I don't know what else there is. And so you're probably going to hear the answer. It looks like there's a 3-second delay. We like that. Nice job. You guys are getting the answers right. So please ask questions if you have them between. I'm watching the chat. There's a tiny bit of a delay. But who has questions? Please ask. If events are independent, and this is the way we test independence. Listen to this carefully. To see if an event is independent, you ask yourself, I know A has happened. And let's say we know it is snowing. Does that tell us anything about the temperature outside? Is snow independent of the temperature? Now be careful, we'll get to disjoint in a moment here. But when they're independent, what's the difference between mutually exclusive and independent? That's a good question right here. So we're always going to talk between the questions for a moment. When we do independent, if I know it is snowing, it would tell me something about the temperature. So the temperature and the snow are dependent. Does that make sense? Now here is our rule for disjoint. For disjoint, we simply ask ourselves this. Is it snowing outside? And if we answer yes, then we would know it can't be 100 degrees. This is what disjoint looks like. If A happens, B cannot happen. Does this make sense for disjoint? If A happens, B cannot happen. That is disjoint. And so there's a good question to ask in the chat right now. If two events are disjoint, that makes them very, very independent or dependent. If two events are disjoint, they are very, very what? Just play along. They are very dependent. Because knowing one happened tells you something about another. Remember, if events are disjoint, one happens, the other cannot happen. So disjoint events are very dependent. But not every dependent event is disjoint. Like studying for this test and making a great grade. You can say that studying for the test changes the probability of your grade. The more you study, the better your grade. But that doesn't mean that they are disjoint. Disjoint means if one happens, the other can't. Independent means the probability of A does not in any way change the probability of B. The classic stuff I use for that is like, if I make a sandwich, what's the probability that my parents call? Like, does it change the probability of my parents calling me? Does that make sense that the probability of making a sandwich today and the probability of my parents calling are completely independent of each other? And I'm trying to change the scenery right now. I should have, let's see here. Let's see if this works. Did that? Let's see if I'm trying to watch what you guys watch. My quick commands don't seem to be up. So we might actually, I'm going to remove this Kahoot stuff right here. So sorry you guys are seeing there we go in the background. So I'm removing that real quick. Okay, let's keep going. So I think we understand how this is going now. Okay, here we go with the next question. I'll start reading it to you guys. The probability of getting a multiple choice question right is 80%. With 5 questions, what is the probability you get at least one wrong? This is a very, very difficult question. Now let's kind of talk through this question a little bit right here. Right here, what you're doing is getting at least one wrong, listen to this carefully while you try to solve it, is the probability of everything but getting them all correct. Everything but getting them all correct. So if you're working this right now, try working it on a sheet of paper. Everything but getting them all correct. 1 minus all correct. And you can kind of help each other in the chat here. This is where we practice. How would you find the probability of getting them all correct? You guys can answer in the chat and help each other out solve this, because this is our time to learn as a group right here. What is the probability of getting all the multiple choice questions correct? Because we want to see the probability of getting at least one wrong. So it'd be everything but getting them all correct. Everyone looks to be working so hard right now. Well, hopefully getting them all correct. Scott, nice job. Scott says 0.80 raised to the 5th power, or 0.80 times 0.80 times 0.80. Because you get the first correct, and you get the second correct, and the third correct, and the fourth correct, and the 5th correct. This is a multiple choice question. That's what it says. The probability of getting a multiple choice question correct is 80%. What's the probability you get at least one wrong? Oh, nice job, Dylan. Thank you for writing it out in the chat. Remember, we're here to learn. If we win, that's all right. So you might be able to win. But Dylan put the formula in the chat for everyone to see right there. He said 1 minus 0.8 to the 5th power. And I think we've corrected this when I've used this before, but should have the right answer now. 1 minus 0.8 to the 5th power. Oh, there we go. I like it when you guys help each other out. So with this in mind, just take a look at the formula. 1 is the probability of everything minus, and then 0.8 is one question right, then raised to 5th power. Now that was a tough one. This is probably the toughest one, and we hit it second. So this is probably the toughest question. The toughest question. How do you do this sort of calculation? So one really great thing is we have on the YouTube channel, we have the review videos, and I go over this in depth. On the Kahoot, I don't think it'll work to do it so in depth. Dylan wrote the formula right there. Thank you so much, Dylan. 1 minus 0.8 to the 5th power. If you read carefully what he's written and put it into words, 1 is everything, minus is but, and then 0.8 to the 5th is getting everything correct. So tell me this much. If you don't get everything correct, you did what? And so you guys should say in the chat, if you don't get everything correct, you'll get what? If you don't get everything correct, you'll get, and everyone will probably say it now, No, you want to failed. If you don't get everything correct, you've gotten at least one wrong. And that's the thing right there. You'll either get them all correct or at least one wrong. And the more you guys talk to me in the chat, the better this is, because that's how I'm communicating with you guys. So does that make sense? You'll either get them all correct or at least one wrong. Yep, and this is the hardest question in the Kahoot, I think. That's why I gave 120 seconds for it. Good job on everyone getting it correct. There's one of these on the practice test, and I think some of the best stuff we're going to do tonight is the sampling and some condition stuff. So we're going to have this down. So we're going to go on and ask all those questions you guys have, and I'll try my best to answer them. First time doing a review like this. So Mr. Krabs in first place. So Hannah asked, can I explain one more time? So when we figure out the probability of at least one wrong, it's the same as everything but all of them correct. So let's do a quick example here again. What would be, just in words, if we said a family has at least one girl. Let's say there's 5 children and there's at least one girl. Just tell me in words, everything but what? At least one girl means what? Everything but what? At least one girl would be everything but... And wait for the chat. Everything but all boys. I think that's what you're saying. So everything but all boys. Not everything but one girl. If you're saying there's at least one girl, everything but all boys. So you have to find 1 minus the probability of all boys. Does that make sense? It's a tough problem to do those right there. This is the complement rule because either you'll have all boys or you won't have all boys. So everything but all boys. You can do the same thing for flipping a coin. What if you flip a coin 10 times? How could we figure out the probability of at least 1 tails? So try to write that in the chat right now. What would be the probability of at least 1 tails when you flip a coin? Just kind of talk it through in words first. Everything but what? If we did flip a coin 10 times and you get at least 1 tails. I see it pretty close. Careful. So if we flip it 10 times, it's everything but all heads. Everything but 10 heads. Lauren has it correct in the chat if you're watching the chat. Everything but all heads. Nice job. Isabella wrote it exactly with the formula right there. Isabella gave you the formula in the chat, and people are saying it in words. And if you notice how she's saying it, 1 minus everything but, and then 0.5 to the 10th power is all heads. Everything but all heads. Thank you, Austin, telling everyone where the practice test is. Watch the chat. Lots of help. Next question time. This is a randomization question. You are looking at heads and tails in this randomization question. So use the 5 number brackets to figure out how many times you get 2 heads. Sorry, there's limited space in these questions. I don't have a lot of room to type the question, but you're looking at a random number table. 0 through 4 represents heads. 5 through 9 represents tails. What percent of the time did you get 2 heads? What percent of the time did you get 2 heads? So look at this random number table right here, and you need to turn those numbers into heads and tails. If you have a sheet of paper, start writing down heads, 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 tails, heads. And so that first sequence of 5, you actually get 1 tails. So you only get 1 tails for that first sequence, or 4 heads rather. Not 2 heads in a row, just in a sequence of 5. How often you get 2 heads? Sorry, there's such limited room to write on these. I do have to explain them a little bit. Some are more, like some I have more writing, but I use the maximum writing to kind of write a question on a Kahoot. So when we look at this right here, let's break down how the numbers work. I'm going to hover it over it for everyone to see. When we look at getting 2 heads, we would need to look at an instance like this right here, where we have right here is heads and heads. Does everyone see this 2 and this 4? I should have put more time on those. I'm sorry about that, Anthony. But if you notice, this 2 and this 4, a 2, so didn't even answer. He goes, no! Does everyone see how we have this 2 and this 4? I should have put a lot more time on the math one. Sorry, guys. But with this 2 and this 4, what does an 8 represent? Look at the key right here. What does the 8 represent? The 8 represents a tails. I know, I'm sorry, guys. There'll be another chance at this. I should have put 120 on that. And so now we have tails. Can you do this right now? Try doing this real quick. Try writing out the first sequence right here as heads and tails. Try that for a moment. This is a good time to practice. In the chat right now, try writing out the first sequence of 5 as heads and tails flips. Try writing this out. Try writing out the first sequence as heads and tails flips. Nice job. That's when you're converting it into coin flips right there. Does everyone see how we have it written out here? Perfect. You are now converting it into heads and tails. And there's only one instance here, 1 out of 5. That's how this answer is found. So when you get a simulation problem, what I wanted to stress with this here is you want to convert this into heads and tails flips. Please ask questions if you have them. Daniel, nice job. Daniel and Kayla wrote out the full sequence right here. If you notice, there's only one sequence where you get 2 heads. Just 2 heads in general. Sorry, since there's limited writing, it's just how often do you get 2 heads in 5 coin flips? I've maxed out the writing on pretty much all these. There we go. Please ask questions when you have them. I will answer all questions that I see. Let's go to the next question. Some of these are a lot easier, and let's see. Thank you, Faith, writing it out. And remember, this will appear with the chat afterwards. You'll get to see the chat and everything. So how you get 0.2, based God asked that, is in only one of the 5 sequences, you get 2 heads. So 1/5 of the time, and it would be the second sequence right here, because there's a head right here and a head right here. So 1 out of 5 times. And if people want to moderate the chat, they are free to, if there is language we do not want in there. We might be able to block/remove that person. If someone knows hide user on this channel, that sounds like a good idea. So the messages from this user will be hidden, and I think I've removed them. So unless I know exactly who you are, I need to know exactly who you are. So so there we go. Let's continue on. On the next question, the researcher is collecting the average amount of potholes per mile. So the researcher is collecting the average amount of potholes per mile. Now remember, I will explain this answer in detail, so if you don't feel like you have enough time, I will go in great detail over this. So the researcher, this is what they are investigating. It is what they are trying to understand. This is what they are trying to understand. And Jessica, we will be very specific on the test. Sorry for the limited amount of words I have on a Kahoot. This is what the researcher is trying to understand. It is going to be their parameter of interest. Nice job there. And I think they're making accounts on us, guys. That is not needed. I think someone missed them. But thank you, Anthony. You're the man, Anthony. So with this in mind right here, we have that the parameter of interest is what we are interested in collecting about. So we are collecting on this item here. The parameter of interest is something that is true for the population. It is something that we want to understand, because imagine this. We want to know exactly how many potholes per mile there are around Knoxville. There is some sort of truth to that. So with this in mind, there is a true amount of potholes, and we want to figure out what is the true amount of potholes. And we go out and we sample, and that's what we're trying to collect on. Are there any questions on this right here? Feel free to ask anything you guys have. I think we probably understand the parameter of interest pretty well. This is for a school, great Nate. This is, maybe we're appearing and trending or something because we blipped on pretty far. So that's, thank you guys for clicking in. Pretty much, that's a great question, Hannah. And so, Dylan, we're going to get into that. We have all the specifics with all the key terms. What's the difference between the parameter of interest and things like the sample frame? The parameter of interest is what we are actually trying to understand about a population. So if we went out and collected the height of UT students, we asked them, like, what is your height? Then that would be the parameter of interest. So the parameter of interest is the question we are investigating. Like, what is the mortality rate of a certain disease? So we might go to hospitals and try to collect information and try to understand the mortality of a disease, or try to understand, the amount of potholes in Knoxville per mile, stuff like that. Does that make more sense? What the parameter of interest is? It is the information we are trying to collect on for the population. Does that make sense to everybody? Seems like we're doing pretty well. we will continue on here. It's going to be an interesting night guide. So what is a keyword to look for the parameter of interest? A keyword would be, what are we collecting on? What we want to understand. What do we want to understand? What are we collecting on? So let's continue on. Here we go. Probability of making a shot is 0.30. What is its complement? You guys should know this right away. What is the complement of 0.30? This one, oh my gosh. I gave too much time on this one. Last time we thought it was too little, and now there's too much. You should get in the mood of doing the complement game. It's a pretty easy thing to figure out. This also goes for P and Q. So P and Q need to be complements of each other when we do the sampling distribution of the sample proportion. P and Q will be complements of each other. And I think everybody knows. Thank you, Isabella. You can type answers in the chat if you want. Just helping each other out. There is the formula, and we see exactly how to do it. Good stuff, guys. And please ask those questions. Let's see who's all on the leaderboard. We got CCC leading the way and Bree leading the way. The answer is to just do 1 minus it, Alexander. So just do 1 minus, and you've got it. Thank you very much. Let's continue on. That was an easy one. For the sampling distribution of the sample mean, what is the third condition? This is a tough one, so be slow on it. Be careful. For the sampling distribution of the sample mean, what is the third condition? We do condition 1, condition 2, and then we have the third condition. But this is quantitative data. And you can actually, well, that looks like a pause. Davis is right. Pause. Anthony says pause also. Davis, I'm going to make you a mod here. It seems like you know what's going on. So, Davis, you're a mod too. And so, there we go. Okay, so here's the issue. So I see a lot of people got this wrong. This is where we need to slow down. So with this in mind, mean and standard deviation give it away. Isabella, nice job answering. So Base Scott, I'll call you BG. BG, you're close. But we need to know how to differentiate between the success failure and the large enough N condition. Are you guys ready to practice with me right now and know the difference? Who's ready to practice? I want to hear those people saying I'm ready to practice. So I think everyone wants to know, why is it going to be the large enough N? So when we do this right here and we try to figure out what the condition is, we have to ask ourselves, and Isabella, I'm going to make you a mod too. Sorry, I lost you in the chat right there, but there you are. We have 4 mods now. Thank you, my moderators. So success failure is for proportions. And the way we do this right here, we ask ourselves, what are we collecting data on? The previous one we collected, let's say, if the road segment has potholes, yes or no. So if we're collecting to see if the road segments have potholes, yes or no, would that be success failure or large enough N? And I'll explain why in a moment. So if we collect to see if it has potholes, yes or no, is that success failure? Faith is exactly right. It is proportions, and it's categorical. So Isabella, you have to ask yourself, since we're saying, are there potholes, yes or no, that is categorical because it's a yes-no question. But what if I switch it to asking, how many potholes are there? And Daniel, you are correct. So if it's categorical, it's success failure, which is the sampling distribution of the sample proportion, the proportion of roads that have potholes. But if the question is how many potholes there are, then it's quantitative, and it's the distribution of the sample mean. So does that make sense right there to everybody? That if we said how many potholes are there per mile, we are looking at the sampling distribution of the sample mean, and it's the large enough. But if we say, does this road have potholes, then it's the proportion of roads with potholes, because we'd answer yes, no to that, and it would be the success failure. So lots of great talk going on in the chat right now. Thank you guys all for helping out. It is for both questions, Ashton, you are correct. In my class, we say condition 1, and it's randomization. Condition 2, 10%. And then you have to pause when you get to condition 3. The large enough N, I'll explain just briefly here. If the distribution is normal, N only needs to be 1. If it's skewed a little bit, N needs to be about 25. But if it's heavily skewed, N needs to be around 100. So N needs to be larger the more skewed it is. And lots of great talk in the chat right now. Thank you so much for everybody for helping out. And ask those questions when you got them. I'll do my best to help out. And we're doing great. I think we'll probably go to about 9:30 tonight. So you guys having fun in the chat? And are you guys learning? Is it making more sense? We'll get a review of this afterwards. Daniel, you seem to be a very legit student. There we go. Daniel, you're a moderator too. Thank you, all my moderators. So, oh, I'm so glad you guys are having fun. I'm having fun too. This is awesome. I want to hear that people thought this helped. I mean, tell me if it helps or not. If you guys think this is successful, we'll do it again for the 3rd. So, yeah. So we will do it. Thank you guys very much. William, I'm trying to think. So many names. I'm seeing if I know all these names. Great job, CCC. I have no idea who that is, but they're leading the way, and I'm glad this is helping. The law of averages is a fallacy. The truth is what? Now this is, try to read them carefully. The law of averages is like when you flip a coin and you keep flipping it, and all of a sudden you're going to get more tails because your coin didn't flip tails enough. We might try Twitch. Who knows? We'll figure it out. So you keep flipping a coin. What is the truth? What is the truth? So we have the law of averages saying that if you flip a coin, that it'll start to average out later on. And we've almost got it all in. Wow, nice job. It seems like you guys know this pretty well. It's the law of large numbers, and past coins do not influence current events if they're independent of each other, and that's when we can multiply them together. And that's why coin flips are great for multiplying, because you can just multiply the probability of getting heads and then getting heads again. So that would just be 0.5 times 0.5. What is the probability? Let's review question here. What's the probability in 2 coin flips you get something other than 2 heads? What's the probability? Write in the chat right now. This is a review question. What is the probability you get something other than 2 heads? Everything other than 2 heads when you flip a coin. I see a lot of 0. I don't know why 0 is coming up. So write it out mathematically. There we go. Dylan, you wrote it out mathematically, and it would actually be 75%. So be careful here. Dylan has the right answer mathematically right there. Something other than 2 heads. And just think for this for a moment. When you flip a coin, what are the things that can happen? I'm going to type it in the chat right now. You can get heads, 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 tails, tails, heads, or tails, tails. So that's what can happen. So what's the probability of getting 2 heads? Just look at the numbers and just look at the things in the chat. What's the probability of getting 2 heads? Probability of getting 2 heads is 0.25. What's the probability of everything but 2 heads? And then it'd be 1 minus 0.25, which is 75%. So I think you guys are getting it. Does this make a little bit better? Thank you guys for typing the Kahoot chat. Please ask those questions if you got it. I'm trying to make sure we can break down every topic right here. This is how we figure out the, and it is the complement. This is how we figure out the everything but. So good stuff. This is the complement rule. It's everything but getting 2 heads. And the formula will be 1 minus getting 2 heads. Well, thank you very much, Alex. I'm glad you guys are enjoying it. Hopefully we don't have too much lag. So let's continue on here. Bree is leading the way. Great job, Bree. A researcher selects every 5th road on the list of roads. So here we go. This is a pretty good one right here. Let's see if you know those terms. They select every 5th road. Hope there's not too much lag. So the researcher selects every 5th road on the listing of roads. Every 5th. They're going to go along. Oh, Isabella likes it. So just wait. They're going to, technically they would take a random starting point, and they're going to take the kth element, based God. You are correct. Ah, Dojo, you are right. It is systematic. You guys seem to know that one. Just to review, systematic is when we take, we start at a random starting point, and then we take every kth element. Please ask those questions if you got them. Hopefully there's not too much lag. As long as you can play Kahoot, we're fine. But you start at a random starting point. That's not multi-stage. You take a random starting point and then take every kth element. I think we're good on this one, right? Good deal. We will go over that. We will go over that, Daniel. Cool. We're going to hit all the definitions. A little bit. I've definitely seen the exam. Garrett asked if the form of the exam will be similar to the practice exam. Yes, and I've seen the exam, and I didn't design this to give you answers to the test, but it hits upon some really key things. It hits upon some really key topics in this. Like, I really think you'll be able to figure some stuff out on the test if you review these concepts with us right here. Bree is still leading the way. Oh my gosh, we got a neck and neck heat. Maybe we'll have to figure out what to give maybe a bag of M&Ms to the winner. The researcher takes too many city roads in their sample. So this is going to induce some bias. So we will do that soon, Mike. So a researcher takes too many city roads. A researcher takes too many city roads. And just to speak to Mike briefly here, we're going to cover all the different types of sampling methods, so you'll get to hear that in just a little bit. So a researcher takes too many city roads. Too many city roads. Now be careful, BG, be careful there. They take too many city roads. Okay, let's talk about this real quick because it looks like some people missed it. So I see a few questions in the chat, which I'll go back to. But this is undercoverage bias, because if you have too much of something, you'll get too little of something else. Imagine, and we're using this example a lot in my class. So, and the game code is at the bottom of the chat right now. So let's say we are trying to ask if students want a Waffle House on campus. Like, our goal is to ask students if they want a Waffle House. And we go to the I Hate Waffle Club house. And I don't know why we'd go to that. I don't know why they exist, because Waffle House is awesome. And we go to them, and they say that they just hate Waffle House, which they do. Well, was that a good sample of students? I know, Waffle House is the best. So was that a good sample of students, or what do you think? What was the bias there? And it's the same sort of bias. We have undercovered. We're not getting a real sampling of UT students. So if we get too many city roads, and we want to examine Knoxville roads, we wouldn't have a non-response, which would mean like we didn't get data from the roads themselves. They didn't respond to us. We couldn't get the response. So if we get convenience bias, that'd be like, so I'm already ruining some of my questions. Convenience bias would be like we took the first 10 roads around us. So, and response bias would be probably if someone took down the answers wrong for the roads, so that would be response bias. The bias is in the response. So when we have undercoverage bias, Daniel points out something big. It's also that you overcover something else. Anytime you look at political polls, you want to make sure you get a coverage of Republicans, Democrats, Independents, because you wouldn't trust a poll that just went to one group. You would say you undercovered blank group, and your poll is probably not accurate. So when they do polling, usually they make sure that they stratify and collect enough of each group. Response bias is when the bias is in the response. So response bias, it's a little hard to do for the roads. Maybe the person collecting on the roads doesn't really understand what a pothole is, and they're collecting the responses wrong on the roads if we're collecting on potholes still. Convenience bias would be if we collect the first 10 roads around our house, because that's when you just collect in such a convenient way that it's not a good representative sample. Nice job, all these answers in the chat, and I hope this is helping out as I cover some of the topics. And each of these will have their own individual question. So each of these will get their own individual question. So for this one, it's just that they took too many city roads. So it's really that they undercovered the other roads, like country roads, roads on the highway. So awesome. I'm glad you're loving it, Alex. I'm glad this is working well. We're going to go to the next question. Remember, we will hit all these topics, and I'll try to cover as much as I can for you guys. So here we are. Let's continue on. Man, we got some great scores going on. UT is 20% juniors. From 80 students, there are 30 juniors. Find the mean of the sampling distribution. So let me explain this to you guys in words. If UT is 20% juniors, and we go out and talk to students, what percent would you expect to see? What percent juniors would you expect to see? So don't overthink it. If you go out and talk to students and UT is 20% juniors, what would you expect to see? We got a lot of answers. We might have the spam bot in here again. So if UT is 20% juniors, what percent juniors would you expect to see? Don't worry about the percentages. It looks like a lot of people got that correct. Ask those questions if you got them. So is it going all right, Scott? When taking a sample for your own experiment, what is the best sampling method? Kayla, that's a great question. If you want, speak to me and I'll talk to you about that. Hopefully the lag isn't too bad. I think we have a spam bot in here, and I'm sorry guys for that. I don't see why someone's trying to wreck our review. That's not a nice thing to do. So it didn't let me answer. I wonder if... Is it going all right? Vols help Rawls. I know. Awesome. Good. Thank you, Pirate, very much. I've got 50 megs up, 50 megs down, but they're trying to hurt our bandwidth. So with this in mind, let's talk about this question. I'm going to still talk about it till we say there's too big of a problem. In this question, I tell you that UT is 20% juniors. Just tell me right now, if you went out and sampled UT, what would you expect to see? If you went out and sampled students, what would you expect to see? What percent of juniors would you expect to see? Just think about it and answer for yourself. If UT is 20% juniors, yeah, you'd expect to see 20%. Anything around that might be a little bit odd if it goes up or if it goes down. But 20% is what we would expect to see. Nice job. I think you guys are getting it. This is where, on the David M. Lane, you would put it at the center of the curve. You would put it at the very center of the normal curve, and this is what you'll have to use on the test. Nice. And this is the sampling distribution of the sample proportion. This is the proportion we would expect to see. And we'll calculate the standard deviation later using p times q over n squared root. So keep that in your mind right now, or your sheet of paper, that if we were to calculate the standard deviation for this, we would do p times q over n squared root. And it is the proportion of juniors we would expect to see. So sorry for all the buffering, everyone. And we would use that, Isabella, for the standard deviation. And there is an exam tomorrow night. So let's continue on right here. Hopefully. Here we are. Gibby is in the lead. Tyler Summers also. Yeah, apparently spicy. Let's continue on. A researcher decides to take 5-mile segments of roads and sample each 1-mile segment within. So a researcher decides to take 5-mile segments of roads and sample each 1-mile segment within. And I can fix this, guys. If it gets too bad, just tell me, and we will just go to me doing the questions with you guys. If I hide the chat, the buffering goes. Okay, yeah, you might hide the chat, yeah. So now be careful here. They're going to take a 5-mile segment, and they're going to sample each one of the 1-mile segments. They're going to take a 5-mile segment and sample each one of the 1-mile segments. Please say if you have a question right now, because the numbers might not be representative to me. But what they're doing is a cluster sample. So they are doing a cluster sample right here. The reason it's a cluster sample is because when we take a cluster sample, they are going to take a census of each cluster. Let's explain the definition of cluster for Mary. When we do cluster sampling, we randomly select clusters. And think of a cluster like a bag of M&Ms. So when we take a bag of M&Ms, that M&Ms is a cluster. So the bag of M&Ms is a cluster. And with that cluster, what do we do to the cluster? What do we do when we have a cluster? That is correct. Well, the Harleon, sorry if I mispronounced your name there, we did a census of it. We take 5-mile road segments, right? And then we sample each one of the road miles in there. Does that make sense to everybody? We're going to take a 5-mile segment, and then we are going to sample each mile. The 5-mile is the cluster, and each mile is kind of the M&M in the bag. Think of the 5-mile as the bag, and then each mile. Now on the practice test, it talks about flights. And we'll mention that in a moment here, Fisher. So on the practice test, it talks about flights. So the flight is the bag of M&Ms, and then each of the people on the flight is the M&M itself. And so stratified, so this is a very important thing right here, stratified is when we acknowledge a difference. And earlier on, we talked about, so, I like that, Maddie. Earlier on, we talked about we had too much country roads or city roads, and we would need to stratify. So how can we stratify this? What is a way to stratify these roads? We could acknowledge a difference and take samples of what? How could we stratify these roads? I'm totally giving away a question later, but how could we stratify these roads? By taking samples based on what? And that's what we're doing right now. City versus country versus city. Exactly, Dylan. Then you're acknowledging a difference. But you're not going to take all the city roads, all the country roads, because if you were to take all the city roads and all the country roads, that would sound a little bit like a census. But we're not going to take all of them. we're just going to say, let's take city roads and country roads, and then we're stratifying by city and country. But if we were to take chunks and then do a census of each chunk, then that is a cluster. So in Stratified, you do a simple random sample. That is correct. In cluster, you take your clusters by simple random sample and then do a census of each of the clusters. I'm going to tell you just briefly here, and I'll answer more questions. But in my class, I like to say to them, let's try this with you guys. How do we cluster sample, let's say, cans of Coca-Cola? How do we cluster sample cans of Coca-Cola? Try this out online right now. How do we cluster sample cans of Coca-Cola? How do we cluster sample cans of Coca-Cola? Let's wait for those answers to come in. To cluster sample cans of Coca-Cola, you'd buy a 12-pack. You'd buy a 24. Now be careful, 243 packs, I like that. So you would buy cartons, packs, all that stuff is clusters. But now, by cases, exactly, Laura. So how do we then stratify soda? How do we then stratify soda? And to stratify, you must acknowledge a difference. To stratify, you must acknowledge a difference. How do we acknowledge a difference? Diet versus regular. What else? There's a lot more. We've got, yes, Diet Coke or Vanilla Coke or regular. Cans versus bottle, that's acknowledging a difference. Cherry versus regular, acknowledging a difference. Dr. Pepper versus Coke, yes. This is all acknowledging a difference right here. This is great. I love buying chunks of Coke, I agree. So you can buy chunks of Coke, but then if you stratify, you're going to acknowledge a difference and try to figure out different ones to get. Pirate is taking down those enemy ships for us. Thank you so much. Water versus smart water. I never understand smart water. we can if everyone likes it. If this goes well, we'll do it again. How does clustering to stratify differ from multi-stage sampling? So clustering is not in itself a multi-stage. Clustering is just that you randomly select 12 packs of Coca-Cola from all your 12 packs and then do a census of the 12 pack. That's clustering. But you could stratify. You could say, I'm going to take packs of regular and diet soda. I've then stratified. And by taking the 12 packs, I am then cluster sampling within the strata. How would I find those clusters? By random within the strata. Inside stratum, you take a random sample. Does this all make sense to everybody? Does it kind of help? Just to review, we'll do one more example. How do we cluster sample donuts? How do we cluster sample donuts? So how do we cluster sample donuts? What would be a cluster sample of donuts? Just think, yes, exactly. You guys are getting it. We go to Krispy Kreme and we buy a dozen. How do we stratify donuts? How do we stratify donuts? What would be a how do you create strata with donuts? Crispy versus Dunkin'. Yes, exactly. So awesome. You guys get it. Glazed versus plain. Exactly. Flavors of donuts. Then you're acknowledging a difference. A baker's dozen would be a cluster of donuts. Good job, everybody. And remember, we'll do some review later on. So here we go. Next question. Gibby leading the way. Which of the following is not a rule of probability? Which of the following is not a rule? We've got the subtraction rule. The set of all probabilities equals 1. The addition rule. And the probability of A has to be greater than or equal to 0 or less than or equal to 1. And so one of these is not a rule of probability. Awesome job, everybody. Seems to be going pretty well. And the one that is not the rule, it's kind of like another rule. It's kind of like another rule. Yes, Dojo, you're doing it right. Now there is the complement rule, but this is not the complement rule right here. So it looks like we might have someone just spamming it. But please ask those questions if you got it. I think, here's the thing. I think in between questions when Kahoot is playing, I think that's when we get the lag because Kahoot's also taking my bandwidth. So I think that's the issue. So the biggest thing is the pausing between questions. So sorry about that. It's chewing my bandwidth. We'll figure out an even better way. There is no subtraction rule. You might call that the complement rule, but that is a rule, but there is no subtraction rule. We don't call it that. An event plus its complement is equal to 1. So something either happens or doesn't happen. There are 276 people watching. Nice numbers. It's great stuff. If we get even more people next time, we'll have to figure out how to, we'll have to do more bandwidth. JT leading the way. Nice job, JT and Bree. This is your second chance to answer a probability question. This is your second chance to answer a simulation question right here. This is your second chance. Second chance right here. Now what you're doing, what percent of the time did you get 2 tails? Write it down. People can write this out in the chat if they want. What percent of the time did you get exactly 2 tails? What percent of the time did you get exactly 2 tails? So go ahead and try to write down what percent of the time did you get exactly 2 tails. It's the same numbers from before. Now we're seeing exactly 2 tails. Is it? Is it? Or did I write the same question twice? I hope I didn't. Let's see. I'm seeing if I'm solving it myself as we do this right here, and my computer is taking off like a rocket. Now be careful. I don't think, Anthony. Careful, Anthony. You might have lost your streak there. And we're probably lagging. That looks... And there's 5 series total. And we're finishing. It looks like people are getting it. Yes. Oh no, you did heads! That's alright. We have most of the series written out in the chat. No, don't worry. And here's the biggest thing. Let's make this very clear. On the test, below these, write heads or tails, or what. Maybe it's heads and tails on the chat. Maybe it's not. But write out what it is on the chat. Write out exactly what it is so you can see it and read it, underline it. And this is a great question to come back and check your work on. So this is a great one to come back and check your work on. Does that make sense to everybody? This one was tails. Is there any questions? Oh no. Can you explain sigma? Where's sigma on this? I think we'll get to that later. This one is a simulation. It's similar to probability questions, but this was a simulation question from chapter number 9. This was a simulation question. It will say, Hannah, sorry, due to lack of words, I try to make the questions as clear as possible. That's actually the max words on a Kahoot right there. I wish I could, I don't know why they limit what you can type, but that's the max words. On the exam, it'll be very clear. And I want to make this very clear. Ask your instructor if you have questions. We're always willing to kind of come over and explain it in another way. We can't give you an answer, but we'll try to make the question clear. Like, be like, are you looking for exactly 2 or at least 2? What are you looking for? So feel free to ask us, raise your hand, and we'll try to make it as clear as possible. And great jobs in the chat, people helping out. Fisher, thank you so much. There are 2 out of 5 of the instances here. If you look right here, we have 9 and 7 right here. That represents tails and tails right here. That's one of the 2. And this one represents tails and tails. So in sequence 3 and in sequence 4, and you will be able to watch this again, in sequence 3 and in sequence 4, you have 2 tails. Does everyone understand? When you get this on the test, write out whatever it is, make sense of it, and then double check these. The simulation ones are easy to make a mistake on. Make sure to double check these. So nice job, everyone. Ask those questions when you got them. Thank you guys very much. We're going to do the next question. Here we go, JT leading the way. JT, nice job. Okay, this is a crazy one. You've got those Harry Potter gross jelly beans. If you eat 3 jelly beans, what is the probability that they're all good? So we know the probability that 1 jelly bean is gross is 25%. We can use the complement rule right here to figure out the probability that 1 jelly bean is good. So the probability is either gross or it's either good. The jelly bean's either gross or good. Those are complements of each other. You guys can write these answers out in the chat if you want. But the jelly bean will either be gross or good. Oh, we've got the answer straight in the chat. Nice job. So when we get near the end, I'll start asking some more advanced questions on this. Oh, be careful, Austin. Austin, what you have written is everything but all 3 jelly beans are good, which would be at least 1 is bad. So you have everything but they're all good. So try to read what you have as a sentence. That'll come later. I have a question in here like that. But we have 0.75 is the probability that it's good. So 0.75 is the probability that it's good. And then we want, and just imagine you're eating them. The first one's good, and then the second one's good, and then the third one's good. Now, if this comes from a really big bag of jelly beans, why am I allowed to multiply these probabilities together? Why am I allowed to multiply these probabilities together? Why can I multiply 0.75 times 0.75? Because each jelly bean is what? What do we assume to multiply events together? They're independents. Nice job, Mary. These are independent events, so we are assuming each jelly bean we try is independent of the last one. So yes, each jelly bean would have to be independent of each other. And so we saw a really good thing earlier. It wasn't the answer, but it could be for a more advanced one. If we were to say at least one is gross, just tell me in words as we finish up this question. Just in words, if at least one is gross, then it'd be everything but what? At least one is gross would be everything but they were all what? So I think you guys might have it. Everything but they were all good, and I think you guys got it. So how will you know if you need to assume that it's a bag of jelly beans rather than a certain number of good versus bad? We always make it clear, like, let's say it's a bag of jelly beans, and we say 25% of the jelly beans are bad. And in my example here, it comes from a factory where we know the factory says 25% of the jelly beans are bad. So truthfully, each jelly bean would be independent of each other. But if you had, imagine if I told you I've got 10 different, boxes, and one of the boxes has a prize. So what's the probability of the first person winning a prize and the second person winning a prize? So I have 10 different boxes. So here's an example for everybody real quick. What is the probability of the first person winning a prize and the second person winning a prize? And could we do that? Only one of the 10 boxes has a prize. And I'll answer those questions in just a moment here. So could we multiply 0.1 by 0.1 to figure out? And Davis, why not? Because if the first person wins, and Kayla, you are actually correct. That is how you would do it. And you can't just do 0.1/10 times 1/10 because they're not independent. It actually changes. And do you see how the probability of the second person winning is dependent on the first? So the probability of you winning would change. And actually, in some instances, if the first person wins, you can't win. Because if they've already won, there's no prize. So you can't just multiply together, because if there's 10 boxes, you can't say, what's the probability of the first person winning and the second? Well, because that's actually impossible. And to go back to another topic, those are disjoint events. Because ask yourself this, if the first person wins the prize that I let open the box, can the second person also win? If the first person wins a prize, can the second person also win? And the answer is no. So they are disjoint. If someone wins, another person can't win. So that would be disjoint events, and disjoint events are very dependent. So I saw a lot of questions. Why is it not 1 minus? I want you guys in the chat right now, just to remind everybody, when we do the 1 minus, what does 1 minus say in words? I want you to read it in words when you see 1 minus. What is 1 minus in words? I want you to just read it in words. So we should start to see that appear in the chat. It's everything but. Everything but, because 1 is everything that can occur, and but is minus. Everything but. What is 0.75 in words? And I'll tell you right now, since there's a tiny bit of a delay, but 0.75 is the jelly bean is good. 0.75 to the third is all 3 jelly beans are good. When you put 1 minus 0.75 to the third together, you're saying everything but all 3 of my jelly beans were good, which means at least 1 was bad. Because either they will all be good, or at least 1 will be bad. That is correct. Daniel, you can do that. That's exactly what you do here, Daniel. I like it. There's calls for pizza in the chat. So what is the math here? The math answer to this question is 0.75 to the third power. 0.75 to the third power. Okay. So here we go. Going on further. Thanks. Little Mega Man, courtesy of my mom. So, good old Patty Stevens here. All right, we'll continue on right here. So, let's continue on. We got Daniel and Anon leading the way. Read the question as a sentence. This is perfect. Do it slowly. This is what we were just doing. Read this question as a sentence. Let's read this as a sentence. The probability... Oh, I gotta be careful. I was about to read this as a sentence. When we see plus, we should think of certain words. Nice job, Alex. You'll be able to watch this later. So when we see plus and we see multiply, you'll be able to watch this later if you want. I think we got this. We're doing pretty decent time. I think we've done this. How well did we do? Nice job. And looks like we're doing great on... Look at this. Nice job. So when you see plus, you should think or. What is the rule for adding words together? I want to see it in the chat. If we add things together, what is the rule? If we add things together, what is the rule? What is the rule for adding things together? To add two things together, they must be... You're telling me the word. What's the rule? You correct, it's or is the word. Or is the word, but the rule is disjoint. Thank you, Isabella. Disjoint is the rule. It is disjoint. Make sure when you add things together, it is disjoint. Now, when we multiply things together, we use the word and. What's the probability of B and C? And when we multiply two things, you are correct on there in the chat, Isabella. When we multiply, two things need to be what of each other? We've been going over this a lot tonight. So when we multiply things together, two things need to be independent. Exactly correct. Exactly correct. Nice job. Good deal. Ask those questions if you got them, but it looks like we're doing really well. I'll pause on anything as needed. Daniel and Anna leading the way. Good job, everyone. We know UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is P? So you have to know what P is in words. P stands for the true proportion. So what is the true proportion? And here's a hint. We know that UT is 20% freshmen. I just gave it away. So we're saying we know this. I know UT is 20% freshmen. So if we were to go out and sample, what percent freshmen would we expect to see? If we know UT is 20% freshmen, what percent of freshmen would we expect to see? And we'd expect to see 20% freshmen. This is the mean for the sampling distribution of the sample proportion. We expect 20% freshmen if we know UT is 20% freshmen. So does that make sense to everybody? Because on your formula sheets, you will see mu p hat equals P. P is, in words, the true proportion. So if you know from the bursar's office that UT is 20% freshmen, that's the truth. And nice job, Lauren. P is the actual for the population, where P hat is the sample. Nice job typing this out in the chat, everybody. So P hat, yes. You've given away an answer for a later one, Keegan. P hat would be the sample proportion. P is the true proportion. And just think about this. Let me ask you this. If I go out and sample, what percent of freshmen would I expect to see in my sample? Just don't even think too hard on it. What would be the most likely percent to see? I think everyone's going to start typing in the chat, and they're going to say 20% in the chat. Because if UT is 20% freshmen, if I go out and sample, I'd expect to see 20%. Exactly. P hat requires calculation, and P hat is what we know is the truth. And it can also be called the mean. It's the expected value, because mu P hat, as typed out previously, is the expected mean of the sampling distribution of the sample proportion. I know it's confusing to say mean when we're talking about proportions, but we're saying what is the expected average, like, proportion. Does that make sense? It's the average proportion we would see. On average, when we take a sample of freshmen, we would see 20%. That's what we mean by mean proportion. Does that make sense? I know it's a weird combination because mean is quantitative often, but when we look at the proportion we would see over time, we would see 20% if 20% is the truth. And P hat is the observed, Isabella. P hat is the observed. P is what we expect, because if UT is 20% freshmen, then I'd expect to see 20% freshmen. And I would observe something in my sample. P hat is what I'd observe. I'd go out and observe 30 out of 200, which would be 0.15. The mean also, Maddie, great question. The mean for the sampling distribution of the sample proportion would be 0.2. That's what we expect to see. So let's continue on. Here we go to the next question. Daniel, nice job leading the way. Pirates are taking down enemy ships. UT is 20% juniors from 80% from, there we go, similar question. UT is 20% juniors. From 80 students, 30 are juniors. Find the standard deviation of the sampling distribution. Now, this is a question we've been covering a lot here. Now, remember, you'd ask somebody, are you a junior? Are you not a junior? To review, this would be the success-failure condition. And actually, we would pass. This is a review of another question within a question. To do the success-failure condition here, I would do NP times NQ. And we just found that P is 20%. So 20% of 80 is 16. And then 80% of 80 is 64. And to answer that question, I would say the success-failure condition is met. We have 16 expected successes and 64 expected failures. So we have more than 10. We need NP and NQ greater than or equal to 10. And yes, we meet the condition. So we have enough successes and enough failures. Excellent stuff. That's the success-failure condition. And it looks like we did pretty well. Who has a question on this? Because the formula for this, nice job. Isabella, thank you very much typing that formula out. P times Q over N square root. And you guys hear me say that all the times in class. P times Q over N square root. So that is how we would figure it out. So Riley, this is a formula question, and make sure to identify which chapter you're in when you're on the test. We would need to find P, which is the true proportion of UT juniors. The complement of P is 1 minus P, which is Q, 0.8. Then the sample size is 80, and then we just do P times Q over N square root. N is the sample size, which is how many people we have in our sample. So N is the sample size. And then it's just the formula P times Q over N square root. And you will get the formula sheet, and this is all just everything underneath the square root. It's not N square root. It's P times Q over N, quantity square root, everything square root. Q is the complement of P. So to find Q, you just play the game. If P is 0.4, Q is 0.6. If P is 0.2, Q is 0.8. So I think we got Parker in the chat. Parker, if you want to help control the channel, Parker, you are in control too. There we go also. Any other questions? Who's got more questions? Keep asking those questions. What is P here? P is the true proportion. It is 0.2. So Megan, thank you, Megan, and Megan's grandmother. Thank you, Megan's grandmother, if you're listening in right now. So this is a proportion problem, so we use P times Q over N square root. If it was not proportions, then it would be S over square root of N, because we're doing quantitative. Tristan asks, how is this not quantitative? So here's the thing. When you ask somebody if they're a junior or not, you'd answer yes or no. So you would answer yes or no to junior. So this is categorical. So remember, look to the question being asked. But what if we asked, what's your GPA? Then it would be quantitative. So if we asked, what's your GPA? It would be quantitative. So we would do that right here. So this is categorical right here. Are there any other questions? I hope we've explained it pretty thoroughly. And Dakota, they have the math up there in the chat. It's P times Q over N squared root. And thank you to everybody typing it out. You can probably assume that it is, if there's a percent, you can probably assume it's proportions. I don't want to lead you the wrong way, but, and Dylan keeps asking, which is a good question, how would you do these without the David M. Lane? A lot of times we might have you draw the sampling distribution of the sample proportion. We would have you draw it, and then you could do things like find the z-score. So you could find the z-score for it. Let me ask you guys this much. Here's a very quick question, and you'll see a lot of the answers in the chat. But what would it be? Let's say in our sample, we found 29%. So in our sample, we found 29%. What would the z-score of that be? In our sample, this is a new p-hat I'm giving you. It says the sample proportion is 29%. What would the p-hat be? So the sample proportion is 29%. What would p-hat be for this question? And so I've given you p-hat. Now you'll subtract from it p. And anyone who wants to write the formula in the chat, thank you very much. 0.29 is p-hat. And now you want to figure out how far away is that from the true proportion. I think, oh, be careful. If I've told you that the sample proportion is 29%, we're going to use the formula p-hat minus p over the standard deviation. So it is 0.09 away, but watch the chat. I think we're going to get some answers here in a moment. If the sample proportion were to be 0.29, Megan has it correct in the chat. Thank you very much, Megan. Maddie, you're very close, just the 0.29 there. If you notice, I picked it and Tristan figured it out. That's 2 standard deviations above. It's a z-score of 2. So watch the chat right here with all the numbers. And you are correct, Maddie. You've corrected. Thank you very much. We have p hat minus p over the standard deviation. And just think about this. This is observation minus mean over standard deviation. And that is a z-score right there. Does it make sense to you that 2 standard deviations above would be 29%? P hat minus p over the standard deviation. We're just seeing how far away is p hat from p. I think you guys might see it. There's a formula, p hat minus p over the standard deviation of p hat. So we've got it. That's a z-score. That could be on the test too. Okay, thank you guys in the chat. Thank you so much. We're going to make sure we get all these topics covered. A researcher selects the first 20 cars. Oh, you guys got this. First 20 roads. You guys got this. The first 20 roads. What is this? We should just start seeing those answers just destroy. Kahoot's probably crashing it. It's all right, though. We got this. You will be given a formula sheet on the exam. You will be given that formula sheet. Sorry, Megan. No sneak peeks of the exam. Thank you to all my students showing up. A lot of names in the chat that I know. Parker and Anthony and Megan. Thank you so much. And thank you everyone else for showing up. I think you guys got this. This is the first 20, and this is definitely convenience. Convenience is when you do something in such an easy way that it inserts bias. That would not be a good sampling method right there. There is no amount of money, just to reiterate, that will have the exam shown tonight. No amount of money. So well, I'm glad you guys are enjoying it. This will be posted later. I think we understand convenience. Ask those questions if you got it. Thank you to everyone asking questions too. Even 5 million. Sorry there, Parker. But we got Mr. Krabs in the lead, voiced by Clancy Brown, I think it is. Great voice actor. 2 events that can be easily added together must be. So 2 events that can be easily added together. 2 events that can easily be added together. You can easily add these 2 events together. Easily add 2 events together. And what is it? We've been covering this a lot tonight. When we add together 2 events, I think it'll be posted soon after, Jessica. This is my first time doing it. We'll find out. And to review, that means this is disjoint. If you've already figured out, disjoint and mutually exclusive are the right answers. So there's 2 right answers here, but it looks like there was a little bit of confusion here. Now, when we add together events, they must be disjoint. Mutually exclusive is a synonymous word. I want you guys to do this right now. Do this with me at home. This is like, it's like lend me your power here. So with this in mind, if they are disjoint, one event happens, the other event cannot happen. If one event happens, the other event cannot happen. So that is what we have right here. So if one event happens, the other cannot. What are examples of this? With grades, let's think about grades for a moment. If you make an A in the class, can you also make a B? So, got the reference, BG. If you make an A, can you also make a B? So are grades disjoint of each other? Are grades disjoint? Yes or no? Are grades disjoint? And those are the same words, Cheng Yao. Those are the same words. Disjoint and mutually exclusive are the same words. So if you make an A, you cannot also make a B. When we say 2 things are dependent or independent, dependent means knowing one changes the probability of another. So when we have disjoint events, making an A depends on making a B. So grades are actually disjoint dependent events. Now I want you to slow down for a moment. When you ask yourself, is an event disjoint? Please do this. Just remember this trick. When we ask ourselves, is an event disjoint? Can the Patriots, this is sad times right here, can the Patriots both win and lose the Super Bowl? Are those events disjoint? To say the probability of winning, probability of losing, are those disjoint events? Are those disjoint events? Are those disjoint? And I think everyone's going to say, you should see this in the chat here in a moment. You should see some answers. They are very, very disjoint events. So we would have the probability of the Patriots winning. They cannot then, or if they win, we didn't know that they lost. So you cannot both win and lose. So you can't win and lose. They're disjoint. When one happens, when you win, You can't then lose. So with this in mind, we could say that the probability of winning depends on losing. So when you ask yourself if two events are dependent, you have to ask, I know that A happens. Does that change the probability of B? And so if you think about things like studying before the test, does that change the probability of getting an A? And yes, grades and studying are dependent events. They're not independent, we would hope. So I think lots of good stuff. I hope that helped you guys out. Please ask those questions if you got them. And the answer is yes, I do watch anime. And so does Mr. Krabs, maybe, and David and Daniel. Nice job. PUBG is winning. So maybe we'll do... I don't even have PUBG, but PUBG is winning. Fortnite is down there on the list lower. Who knows? A researcher selects their sample based on the percentage of highway, country, and city roads. A researcher selects their sample based on highway, country, and city roads. Now, this is a good question because this is a review question now. So they're selecting based on this. They're going to say, okay, we need 20% country roads, 40% city roads, and 40% highway roads. They're going to make their sample based on this, based on differences. Exactly, Isabella. So exactly. Let's see some anime advice online. So good stuff. It is stratified because we are acknowledging a difference. And we've been reviewing this a lot tonight. So I'll answer some questions related to it. But in strata, you acknowledge a difference. And we'll try to go over that again, Hannah. We'll definitely try to hit that question again and help you guys out. So when we acknowledge a difference, we are making strata. And the thing is, I want you guys to remember this. When we take everything, we're taking a what? So if we take everything and do a census on it, we're doing a what? If we take everything and do a census on it, we are doing what? A cluster. So those are the kind of words. We'd have to randomly select clusters, like a whole box of donuts, and then we got to eat that whole box. Or a whole 6-pack of Coke, and then test out all the Cokes. But if we do Krispy Kreme versus Dunkin' Donuts, that would be stratified. If we do, I can't think of the sodas anymore. If we do diet versus regular, that would be strata. And the answer to favorite anime, maybe I'll answer one random question between each of these. That's such a hard question. I think Death Note has to be up there, but Trigun might be up there too. There's so many good ones to pick from. And next question, we have Mr. Krabs still in the lead with David close behind. And let's see. A researcher lists all roads and randomizes the order, then selects the first 50. Now be careful. A researcher selects now it's not just the first 50. Don't be tricked. Don't be tricked. A researcher gets all the roads, randomizes them, and selects the first 50. So here we go. Now, they're not just selecting the first 50. They've randomized them. And then they select the first 50. I think we see the answer. Nice job, everyone. And I put a little trick in there that they select the first 50. It's not convenience because they're not just picking the first 50. It's totally random. I don't even know what super simple is. I know Inuyasha, and I've heard of Sword Art Online. So a lot of good animes in the chat. So good stuff. I think we got this right here. We'll continue on, and please ask those questions if you got them. I hope you guys are having some fun and playing along. Here we go. Oh, One Piece. That is, yeah, that's a lot right there. Mr. Krabs leading the way. Here we go. The roads that the researcher samples. We're going to pause after this one and do a little talk. So the actual roads that the researcher samples. The actual roads that the researcher samples. The actual roads. I'm totally giving it away right now. The actual roads the researcher samples. I've heard that one's a favorite of streamers, Daniel. The actual roads. And then we're going to break down this question right after this one. Oh, be careful. Okay, so you guys ready to break this one down and see how it works? So the way this works, I want you guys to follow me along here. We're going to do a review question now. If I go to UT Library from 2 to 5 p.m. to understand UT students, did everyone hear that? I go to UT Library to understand UT students. What would be my population of interest. I go to UT Library to understand UT students. What would be my population of interest? I go to UT Library to understand UT students between 2 to 5 p.m. And the answer is UT students. That is exactly correct. Now let's break it down. We got lots of friends in the chat today. So now we go to the next level. The students I have access to would be the sample frame. So tell me this much. I like it too. I like Charlie in the chat right here. The students I have access to, which students did you hear me having access to? So when I said I go there between 2 to 5, I think I see the answer in the chat already. Nice job, Hannah. Yes, the sample frame would be the students I have access to. Lots of good answers in the chat right now. The students who are in the library between 2 to 5 are the ones I could have theoretically sampled. Next, we go to the sample. The sample would be the students who actually spoke to me. So as everyone see, as we break it down here, when we go from population, is every person or thing we're interested in, all UT students. Next, we go to sample frame, and that is the people or things we have access to. Next, we go down to the sample, which is what we actually collect on. The parameter of interest, Daniel, could be something like, let's say we ask them, how many hours a week do you study? Then we could be doing the sampling distribution of the sample mean if this was like a test question. We could ask them, do you study in the library? Which would be the sampling distribution of the sample proportion if they study in the library or not. The parameter of interest, or the parameter for the population, lots of different words to call it, but it's always parameter, is the thing we are collecting on, the question. So we could be collecting on the sample proportion and trying to understand the true proportion. So if we collect a sample proportion, we want to understand the true proportion. So does this make sense? And I'm going to throw one more question in here. So let's say this was a test question and it was, we were asking students how many hours a week they study. We'd have condition 1, random. We got to randomly collect these students, which we might not have done. Condition 2, we need to sample less than 10% of all UT students. And the third question, the third condition, if this is a sampling distribution of the sample mean, and we're asking them how many hours a week do they study, and this is just a kind of quickie question, what would be the third condition? Hannah, you are correct. It is large enough. Because remember, I'm asking a quantitative question for the sampling distribution of the sample mean. I asked them, how many hours a week are you studying? And this is large enough. This is, I've got, I think, a few more questions that go over this, but it would be large enough N, because it's quantitative. Does that make sense to everybody? When you say how many hours a week do you study, that's quantitative, and it is large enough because it's a quantitative question. If it was success failure, it would have to be like, do you study in the library, which would be success failure. And that would be a categorical question, so we could do the sampling distribution of the sample proportion from a categorical question. Does that make sense to everybody? I think we're good. We are using OBS. Fun stuff right there. We are using OBS, and I use Camtasia when I make videos. We will continue on. I think we're doing well. Please ask those questions if you got them. I'll spend time reviewing between questions. Mr. Krabs, nice job. Thank you to everyone playing along. Man, we got 267 people watching. 2 events that have no influence on the probability of each other. 2 events that have no influence on the probability of each other. We're basically giving this away. If we know A, it has no impact on B. If we know, like, okay, it's raining today, are the Red Sox going to win their game? And let's say it's not raining in Boston. We just know it's raining here in Knoxville. Raining in Knoxville and the probability of the Red Sox winning. Those are what events of each other. And so exactly it is, you know A, does that change the probability of B? And you guys got this. And this is the way you have to ask yourself. They're independent. Lots of good chat going on today. So we have 2 events that are independent of each other if they have no influence of the probability of each other. No influence on the probability of each other. Remember, ask yourself, I know it's raining here in Knoxville. Does that change the probability of the Red Sox winning? Let's have you guys in the chat right now type out some independent events. Tell me event A and event B. You have to tell me 2 events where knowing one does not change the probability of the other. So you know one thing, or It could happen or it could not. It's either raining in Knoxville or it's not raining. There's a probability associated with that. And the Red Sox either win their game or they don't. Those are independent events. So tell me two things. Driving a car and cooking breakfast. And you could say two separate people, like me driving my car today and my parents cooking breakfast. And actually, shark attacks and ice cream sales would actually be very dependent because the amount of ice cream sales would depend on shark attacks. That's actually correlation causation, but those are kind of dependent. But due to a third kind of, so I guess there's a lurking variable there. That's a complicated question. Raining in Canada and snowing in Tennessee. Precipitation around the U.S. and the globe might be dependent. Like us getting rain or snow might depend on other people getting rain or snow. Vols winning and raining in California. Perfect, Kevin. It's like, I know the Vols won. That tells me nothing about raining in California. Me failing the test from if I work this week. But working and a test grade might be dependent. The more you work, your test grade, it's raining outside rain because rain does not care. There you go. Sleep and weather. Yes, your sleep. The weather does not care about your sleep. Alabama winning and Mr. Higgins doing a cry chop. I like that. So you have to know A, and then the probability of B does not change. Exactly. And so your roommate's grades might be independent of yours. So there we go. I think we got the idea what's going on. Nice job, everyone. We'll continue on. Mr. Higgins does do karate. I think he's a third-degree black belt now. Congratulations to him. He's Taekwondo third degree, I believe. Mr. Krabs leading the way. Man, this has been fun, you guys. We're going to go another 30 minutes or so. Hope you guys have been liking this. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is N? This is a nice, easy one here. You just have to know what N is. This will help you out with your formula page. What is N in this question? Nice and easy. We've been using this same sort of question a lot to do calculations. So what is N? You guys got it. N is just sample size. And yes, what is the third condition for this one again? Remember, I have to go up to students and ask them, are you a freshman? What is the third condition on this one? I'll say it in a moment here, but what is the third condition if we were to do this? The third condition for walking up to people and saying, are you a freshman? Would be the success failure because it would be proportion. It's success failure. And we're going to keep going over these conditions, Jack. The reason this third condition is success failure is look to the question. This is how you know what the condition is. Say, what did the researcher ask? And they asked a yes-no question. It could be answered yes or no, like, are you a freshman is yes or no. So we are trying to figure out the sample proportion of freshmen. It is categorical, and categorical is success failure, the sample proportion. And you have to ask a categorical question, which leads to yes, no, and then we find out the proportion of yeses. Does that make sense? The person who asked it, did that make sense? It's down below on the game, Crazy 9 Cat, flying across the screen. Does that help out, Jack? Does that make sense to you? Thank you so much, Pirate. So, thank you. Nice job, Jack. I'm glad you understood it there. Always ask those questions. I'll try to explain further. Ask all the questions in the chat. So let's continue on to the next question. Man, we'll have to figure out who Mr. Krabs is. Nice job. So here we go. For the sampling distribution of the sample proportion. Oh, what is the third condition? You guys got this. This is questions like, I don't want to say the same thing, like, do you want a Taco Bell on campus? Do you want an In-N-Out burger? That's UT's going to go around and ask, do you want an In-N-Out burger on campus? That's the new, what we might put in the student union. So do you want an In-N-Out burger on campus? So think about something like that. Feather or pearl? Well, that could be a question too, yes or no, basically. Could do Whataburger from Texas. You guys got it. So remember, these questions are like, they have to be yes, no to do success failure. Success failure is, and there's no real order of the conditions, but I like to say this is the third one because it makes sense. We always want to collect things randomly, which means we make sure we don't do a convenience or we have undercoverage. We want to have a random collection which gives a representative sample. So we want a representative sample. We take less than 10% of the population, and then we make sure that for this one, we have the success failure condition met. Isabel, you ask a great question. Let's say a researcher wants to know if UT students think we'll win a championship next year. And that's pretty yes, no right there. Like, The researcher has to go around and say, what proportion of UT students think will win a championship? They talk to 500 UT students. That would be N. From those 500 students, 400 say will win a championship. So 400 over 500 would be P hat, and we would have the sample proportion there. And it could say the researcher knows that 85% of students think that will win a championship. That would then give you P. So 500 out of 500, I like that. So that question could be something like a researcher knows, let's say UT knows that 20% of the students here are freshmen. They go out and take a sample, and just by virtue of we're asking if people are freshmen or not, it's success failure. So sampling distribution of sample proportion means categorical, while sampling distribution of sample mean is quantitative. Meg, you are exactly correct. That is it. When you see sampling distribution of sample proportion, it is categorical questions like, are you a freshman? Will we win a championship? Is In-N-Out Burger what we want at UT? Meanwhile, when we do the sampling distribution of the sample mean, it has to be like, how many years have you gone to UT? Which is a different question than, are you a freshman? How many games will we win next year? And how many fast food places should we have at UT? If you notice, each one of those responses would have to be a quantitative response for the sampling distribution of the sample mean. Does this make sense to everybody? How to differentiate between the sampling distribution of the sample proportion versus the sampling distribution of the sample mean? Key stuff right there. I think we might have it. I hope that makes sense, the differentiation. I don't even know what people want in chat right now. So I think we're good. Good deal. You're welcome, Maddie, and you're good. And good job too, Meg. So we'll continue on. Huzzah. Mr. Krabs. Okay, the roads the researcher wants to understand. These are the roads they want to understand. Be careful. This is like, let's understand Knoxville roads. Now, we haven't even looked at the roads we can get to. Hint, hint, hint. And we haven't collected on roads. This is the roads we want to understand. It's like, let's understand Knoxville roads. Here's the ones we have access to, and then we collect on certain roads. If you notice, I'm breaking it down from each level for you. But we have roads that we want to understand. This would be the population. Oh no! Now, I see a lot of people said parameter of interest. The roads we want to understand is the population. It's like, let's go out and try to understand UT students. So if we want to understand UT students is the population. What I want to understand about UT students is the parameter of interest. So to break down the question again, we're going to do a whole new thing here. Knoxville wants to know what people think about, let's say, Knoxville wants to know what people think about the Vols here in Knoxville. Knoxville wants to know what people think of the Vols. Does that make sense? So what would be the population that we care about? We want to know what Knoxville thinks of the Vols. So the population would be Knoxville. We want to understand Knoxville. Knoxvillians, I like it right there, Hannah. So Knoxvillians would be the interest. Laura got it too. And then the people we actually have on our list that we can get a hold of would be the what? The people we actually have that we can get a hold of would be the sample frame. And then the people we actually speak to would be the sample. If you notice, each time you break it down from population is everyone we want to understand, where sample frame is everyone we have access to, and the sample is everyone we actually speak to. Now, I snuck in there the parameter of interest. What is the parameter of interest for this question you just heard me say? Maybe, Hannah. Then I don't quite know if that analogy works. So in this one I just gave, and I'll circle back to the question, Savannah. Exactly, Laura. It is what do people think about the Vols is the parameter of interest. And we could say, do you think the Vols are going to a championship next year? So that would be the proportion of people who think the Vols are going to a championship. And Lauren, you're basically correct. The only time that, and it is true that each one could decrease in size, but if you have a census, like the U.S. Census, then your population would be all people in the U.S., and you must have access to all of them, and then you would have all of them in your sample. But even a census the U.S. Census isn't true because I don't think they get data on everybody. But the point of a census is to get everybody. So they either decrease in size or stay the same. It's possible to sample everyone in your sample frame, but you could never have a sample frame that's larger than your population. Isabella, feel free to ask some questions. We're pausing on this for a moment, and I'm going to just give the definitions again. The parameter is, the population is every person or thing you're interested in. The sample frame is every person or thing you have access to. The sample is every person or thing you collect data on. The parameter of interest is what you are collecting on and trying to investigate. The parameter of interest is what you are collecting on and trying to investigate. Thank you very much, Crystal. The sample frame is every person or thing you have access to. Does this make sense to everybody? So just to review another quick question like the airline one. So an airline wants to understand their customers. They go out during a 2-week period and collect data from 30 random flights. An airline, and they ask the customers what do they think about baggage fees. So ask yourself, they want to understand their customers. They're going out during a 2-week period and they collect on 30 flights. They want to know what customers think about the baggage. Like, do you like the new baggage thing we have? It's a yes, no question. Do you like our baggage fees? I don't know why anyone would say yes. So what would be the population? The population would be what? The population would be, and we might start seeing in the chat here in a moment. I'll review it once again, and I'm going to ask the questions and break them down. An airline wants to understand their customers. They go out during a 2-week period, and they collect data from 30 flights. They want to know what customers think about the baggage fees. And the breaking it down would be, they want to understand their customers. That's the population. All people who fly that airline. Everyone who flies the airline. The sample frame would be everyone who flies during that 2-week period. Because if they sample 30 random flights, then they could have theoretically sampled anyone from that 2-week period. The sample would be everybody who they sampled from the 30 flights. Everyone who actually spoke to them. So everyone from the 30 flights. And this is like the practice exam that John's asking about. It's on our website, and someone might throw you the link in a moment here. But that would be the people who actually spoke to you. And then the parameter of interest would be what people think of the baggage fees, because that is what we are investigating. Did this make more sense to everybody as we break it down, as we go through the questions that are on the practice test 2 right here? That is correct. Parameter of interest is how people feel about the baggage fees, because that's the question we are asking them. We're trying to understand what is the true proportion of people who dislike our baggage fees, because parameter is the truth for the population. So what do these people really think about baggage fees? That's what we're investigating. The parameter of interest, why it's called parameter of interest sometimes, is what we are investigating. So I think maybe we have some ideas and we might circle back around. I'm glad some people are getting it. The sample of that airline's example is biased, and it could be. It could. Thank you, Anthony. Thank you very much for putting in the chat. So I think mods have the ability to put things in the chat, and thank you, my mods. So good job. We'll circle back, and I'll answer some questions at the end. David leading the way. Thank you, everybody playing along this whole time. Okay, which of the following is a rule of probability? And so we've done one like this before. What is a rule for probability? Oh, which of the following is a rule of probability? Yes, yes, yes. Good. Does the Quizles help out on the test? Yeah, I think my Quizlet helps out. I think the quiz is pretty good. I have a Quizlet for the first, but I don't love it. I like the Quizlet for the second. So I've gotten a lot of good advice on Quizlet, and I think it's pretty good. So some of these are from the old stuff. You should never remember. Well, you should remember them, but you should never use them again on a test. You guys did it. Probabilities are between 0 and 1. Something either and thanks to any mods with the Quizlet link. It is also on the site, so all that good stuff. The answer is that probabilities are between 0 and 1. Probabilities are between 0 and 1. Any questions on this right here? I think this one's pretty straightforward. Yes. Okay, I'm going to go to the next question. So here we go. Thank you, Anthony, leading the way. David, Mr. Krabs, my gosh, and Daniel. Here we go. Last few questions. The researcher is unable to get information from certain roads they selected. So they can't actually get to these roads. They just can't get to these roads. There's no data for them. They don't get the data. So what is going on here? These are roads that they cannot get to. It's not that they collect information that's wrong about these roads, that someone, doesn't know how to take the data and puts a bad response in. It's not that they took the easy roads to get to, and it's not that they took too many or too few of one roads. This is non-response bias. And think about this. Just think for a moment. If we can't get to these roads, do you think these roads might be different from other roads? Like, if these are roads we can't actually get to, like it's like, oh, we couldn't get to these roads to collect data on them. We don't have any sort of data or response from them. Do you think these roads might be different from other roads? So non-response specifically means that we don't get a response. We don't get any. And undercoverage would actually have to deal with, great question, Lauren. Undercoverage would deal with the way in which we kind of selected the roads we were going to sample. Undercoverage would be like if we purposely didn't like even consider getting these roads. So if we try to get this and we can't get a response from it, that's considered a non-response. So yes, and so let's try it another way. One of the famous ones is if, imagine you're calling up people to try to get them to tell you what they think about, the UT Vols. And so you call people up and they just hang up the phone when you say, I'm doing a sports survey. So you can't even do the sports survey with them. They just hang up the phone. That'd be what bias? If you call someone up and say, hey, we're doing a sports survey, and they just hang up the phone. That would be non-response. And if we actually had an undercover, so that'd be the worst. That'd be pretty bad. So that'd be non-response because they're not responding to our survey. So when you see non-response, it's that you had access to this thing, you tried to get it, and you couldn't get a response. Does that make sense what non-response is? Like you actually tried to sample it, and then you couldn't get the sample for it. But to do the other ones, if we do undercoverage bias, what if we did a sample, we called people and said, what do you think of UT sports? And we just called all numbers in Florida. What kind of bias would that be if we said, what do you think of UT? And we just called Florida? It's a horrible idea. So if we called just people in Florida and we said, what do you think of UT? Response would be that they're lying, or it would definitely be undercoverage. It'd be undercoverage because if we're going to ask people what they think about UT, and if it's like some nationwide survey, we shouldn't just limit it to Florida. That'd be a horrible idea because they differ in their responses than we think they would, than the rest of the nation would. So we would want to make sure we maybe stratified and said, let's get people from Tennessee, Florida, all around the nation. So this is an undercoverage here. What if you're hanging out with your friends and you're from Florida and you're up here for a game and people say, what do you think of UT? And you're like, oh, I love UT. And the researcher's like, thanks for your answer. If you notice what I'm putting in there right now is a response bias because that person actually responded to us, but their answer wasn't the right answer. And sometimes it's the question wording. Like, I think there's one about, do you think it's fair that teenagers can go to war, buy guns, but they can't buy a beer till they're 21? There's one of the, there's a Mike Pearson question that asks you that. That's like, what kind of bias is in this question? And that question is leading you to be like, yeah, it's not fair. But that's a very biased question that gets people to respond a certain way. And especially if people lie or if the question mixes them up, then the responses have bias in them. That's what response bias means, is if the responses we are getting are not truthful, not accurate to what we're trying to investigate. Does that make sense what response bias is? It's when the response actually has the bias in it. To get non-response bias, we don't get a response. So if we called people up and they hang up the phone, that's a non-response. If they somehow differ, like they're like, I don't want to take a sports survey. I mean, they might have an opinion, but these people who don't want to take the survey might differ in their responses and they're not responding. So to get response bias, there has to be a response. And so does that help with these different types of bias? Convenience would just be if you called, or if you just put the survey on Facebook. If you talked to your first 50 friends you saw, that'd be convenience bias. Does this help with the types of biases here for those wondering? Because we're nearing the end. I want to make sure I cover the topics. Don't speak of them. I think we might have this one down. Yes, we didn't even get the response. That's correct, Lauren. You are correct. If they purposely left them out, that would be undercoverage. Lauren, you hit upon it perfectly. They were unable to get the response. It's non-response. If they did not put in country roads to even try to get, that would be undercovered. They undercovered in their sample. People want to play Mario Kart. So I think we're getting these down. Good stuff. So here we go. Next question. Next question is next people on the leaderboard, David, Daniel, and T. Colum. Here we are. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is P hat? So what is P hat for this right here? We figured this out earlier. Remember what P hat means as a definition. P hat is the sample proportion. P hat is the, oh yes, we got the answer in the chat. You should know this. What is the third condition for this one again? Because we're asking people, are you a freshman? Are you not a freshman? What is the third condition for this one? You can just type that S/F. Yes. I think the third condition is success failure, for those wondering. And good job. I think you guys figured it out. And it's randomization 10%. There is no actual third condition. I just like to call it the third because it's the one that's different for this right here. Are there any questions about this? We've been doing this one a lot just to review the notation in it. Here's one last big tip as we near the end of this, and we'll probably end right at 10 or so. When you get a question like this, please write the notation on it. Right here, you should write, for this question, for this right here, you should write P. We know UT is 20% freshman. For this question, you would use the formulas mu P hat equals P, and you'd also use P hat times Q hat over N quantity square root equals standard deviation of P hat. This is the sampling distribution of the sample proportion. So 20% is P because we know that. We have 200 is equal to the sample size, which is N. And 30 over 200 is equal to P hat. A question could give you P hat. We could simply say, in our sample, we found 25% freshmen. So you could just get the answer right there. So we got it. So I think, are there any last questions on this? I think you guys understand this one, the notation. Please on the test, write your notation. It's going to direct you to what to answer in. Why would P hat not be 30? 30 is just the amount of successes we saw in the sample. In technical notation, 30 is actually X, and X over N equals P hat. So 30, you could say 30%, but that's not the answer to this. 30 is how many freshmen there actually were. 30 out of 200 is the sample proportion of freshmen. Does that make sense, Josiah? 30 over 200 was the proportion of freshmen we saw in our sample. And just try to read that when you have P hat. Awesome. Thank you, Spicy D. My email is bs@utk.edu. So, oh, you sent me them already. Thank you so much. We're going to always try to improve this, but I appreciate it so much. Thank you very much. So, and Josiah, great questions, Josiah. So, do we cover sigma in this video? Not enough. I don't think I put that in here. We can talk about that at the end. Oyoka, we can talk about that at the end. David and Daniel, my gosh. You guys got something I do on the exam. P hat is the sample proportion. And the last question, what is it? What's it going to be over? The list of roads the researcher has access to. This is pretty much a review question. The list of roads they have access to. The roads they have access to. The roads they can actually sample. The roads they have access to. Ah, yes. So remember, the roads they want to understand is the population. The roads they have access to is the sample frame. The roads they actually collect on is the sample. Oh no, Megan, sorry. Great job. Man, we're going to see these winners and we're going to just talk for a moment longer. Man, good job, everybody. And please email me those questions if you have it. Let's take some last questions right here. Who won? It says I've lost connection to the server. That's always good. So we will post this. It looks like David won. So maybe it worked, maybe it didn't. We got the results. Let's do this right here. And let's hop over here. Let's go to I should have pulled out my throne earlier on and just been kicking people off. So I've got I got my good throne right here. So the last question the last question, it's so bright right now. So I thought you guys might like this at the end. Not King of the North yet. What was the last question? Oh yeah, it was the roads we have access to. is the sample frame, the roads we have access to. So I know you guys are getting a kick out of this. Okay. So this is a good idea suggested to me. I'm so glad this worked out. A little nice surprise. I hope you guys were able to learn a lot tonight. Any last few questions here for me before we get off? Thank you guys for taking part in this. This was a new idea that we tried out. We had 200 plus the whole time. One of these days I might start playing Fortnite. Who knows? I used to play Transformers War for Cybertron. I don't play Fortnite right now. I don't know. I need to get back into shooters maybe one of these days. I don't know. How many points should I email you from tonight? No points tonight. Can I teach every single class I take my next semester? We got some Fortnite versus PUBG fight going on. No Overwatch for me either. I don't PC enough, so I'm Nintendo Switch and all that stuff. So if you guys got advice, do you think the second exam has less material? And we'll go over how to do the third exam too. I'm always up for advice, all that good stuff. No, I don't play Overwatch or Fortnite or PUBG. I just don't play enough. I don't play enough PC, even though I got a pretty decent one, but I don't. I need to. I've got everything else. Smash 5, definitely not a port. Smash 5, definitely not a port. Definitely not. Confirmed. Here, that's what I'm confirming tonight. Is Smash 5 is not a port. I wish. League of Legends, no, I don't. I just play like people were asking earlier about Dark Souls. Hop on. If you guys have test questions, feel free to ask. I'll answer test questions. We'll just spend a moment or two more because I'll probably hop off in a moment. But I didn't play Smite either. P hat, let's go back to the test question. Amber Green says, can you explain P hat more, please? So I think, let's go back. The Kahoot's still crashing, it says. So I'm going to give you some example questions here where I want you to figure out P hat. So Amber, listen up. Here's some questions for P hat. A question says, we go out and talk to 400 students and we ask them, should UT have an In-N-Out burger on campus? I want to try In-N-Out. I've never done it. Never tried In-N-Out. So 300 out of the 400 say we should have an In-N-Out burger. What is P hat? So think about it for a moment. P hat means the sample proportion. You're welcome, Isabella. So P hat is the sample proportion. We spoke to 400 students, and 300 of those students said we should have an In-N-Out burger. So 300 out of 400 would be the sample proportion, which is 0.75. So that is how you find the sample proportion. You just say, what proportion answered the question this way? The way to write it, you can write it with x over n. So x over n is the sample proportion. That would be the proportion of people who responded we should have a In-N-Out burger. I just keep thinking about In-N-Out burger. The large enough condition, we see this question here, and I think there was some advice for it. Crazy questions online. Could you explain the large enough condition? The condition is when we have the distribution of the sample mean, we want for the distribution to be normal. So when it is normal, the distribution the sample size of n can be very small. When we start to get something that's a little bit more skewed, the more skewed it is, the larger n needs to be. Now there's three important numbers to know, and especially my students should know this. What are the three numbers you should know? What are the three numbers you should know for when it's large enough? Mario, you're kind of right. The three numbers would be 1 for normal, and people often forget this one. So 1 for normal, and 25 for skewed, and 100 for very skewed. And there's a lot of synonymous words for this. So if the distribution is normal, when we increase n, it becomes more normal. Does that make sense? So if it's normal, having a larger n will just make it more normal, right? So it will be normal if n is 1. So that's fine. But if it's skewed, n needs to be larger. Once again, to repeat, if the question says it's kind of skewed or has a light skew or something like that, how large does n need to be? If the question says, this will be up afterwards. If the question says it's skewed or light skewed, it needs to be 25. If the question says it's heavily skewed, how large does n need to be? If it says it's heavily skewed, how large does n need to be? N would need to be 100. So that's the way it works. The more skewed the sampling distribution, the original distribution is, the larger n needs to be. And what kind of question am I asking if we know the shape of it? So, you're welcome, Mario. What kind of question are we asking if we know the shape of the distribution? If we know the shape of the distribution, what kind of question are we asking? And Hannah, I'll answer that right away after this. If we know the shape of it, what kind of question are we asking? We're asking a QRC question. So, Anthony, good advice there. We're asking a quantitative question if we know the shape of it. Does that make sense to everybody? It has to be like, how many burgers do you eat a week? How many hours do you study a night? How tall are you? These are all quantitative questions which lead to a shape of a distribution that has a histogram. These are all large enough n conditions because we ask a quantitative question. Quantitative is the large enough n, and then we'd know the shape of it because we could say the amount of hours people study is right skewed. And so Hannah asked a great question, what to do. Don't make sure to get some sleep. And the test is later tomorrow night. Get some sleep. Highly suggest that. But to do some studying, one, I think the Quizlet has some pretty good stuff on it. If Anthony or anyone wants to post that in the chat again, which the chat should be available afterwards too. But also we have some review videos posted. The review videos go over each chapter, and I try to make it clear a lot of the techniques you're hearing from me now will be in the review videos. The practice tests, I would probably watch the review videos, look over the notes, any notes you have also. But if you guys want to throw that, thank you, Anthony, so much. My mods tonight, my pirate, doing a great job, knocking it out of the way. Awesome job. Thank you so much. And yes, thank you guys, all my mods, and a lot of my students became mods because I was like, I know who that is. I know who that is. They're in the online chat a lot. The review videos are here on this channel. If you go to the playlist, I've got playlists on this channel. So you'll see test 2 playlists. I'm glad you guys liked this. Please tell me how you did or didn't do. I hope that person who made a 87, I think, on their project thought that was a good grade. They said this guy helped me with my project and I made an 87. I hope that was like, yay, I did well, not I got an 87 because of him. No, I hope. Oh, no, that's me. I don't think that wasn't you, Anthony. I don't think. Sure, like the video if you want. I haven't even looked to see how many likes we have because I don't know. My first name is Anthony. So I'll see. Tell me what you guys think of all this stuff. If you liked the Kahoot, I think we have some advice. Any last minute questions? I'm gonna get off here at 10. Throw me those last minute questions you guys got. I'm gonna go 4 more minutes here. 4 more minutes, and then we're hopping off. But are we reviewing in classes tomorrow? Probably. It's Scott. Yeah, it's Scott. That's what I thought. Maybe that's instructor dependent. Probably, I would say. Probably. So I'll be. There we go. Well, I think. Please ask any more questions. We're going to stay for 3 minutes. Wait, no. Well, we don't have class tomorrow, correct? Yes, we don't have class. We have class on Tuesday, Thursday. Thank you, Davis. I'm glad you enjoyed it. So anyone can swing by. So when and where do average for this test go up? I think the average for this test will be higher. I hope. The biases, Paul wants me to talk about bias for the last little bit here. So here's the biases and the way they work. When we do a phone survey, if we have convenience bias, we might call maybe the people we have phone numbers for. Like, let's say I want to understand people in Knoxville, and I just call the people I know. Well, in Knoxville, that would be a convenience sample right there, and that'd be tons of bias. So if I just call the people I know in Knoxville, that'd be convenience bias because I'm doing it in such an easy way. So convenience bias is when we have something that just makes it easier, and it just fills it with bias. It's a horrible thing. Voluntary bias is if I were to say to my friends, which it's a little bit convenient still, but I was like, hey, who wants to take this survey? And they're like, oh, I'll take the survey. So they're deciding to take the survey, and that adds in bias because people are actively deciding to take the survey. If I'm doing this phone survey again, and I'm actually doing it right, and I call people in Knoxville, and I call them up and I say, hi, I'm doing a Knoxville survey on what do you think of the roads? And they hang up the phone. Well, that would be non-response because they're not responding to me. Maybe they're like, I don't drive, so I don't need to talk to them. And maybe that's my first question, like, do you drive? So that's putting in bias because I'm not talking to people to find out like what percent of even people even drive on the roads, because the people who are like, I don't want to take the survey, I don't need to, are hanging up the phone, and they're not in my survey, they're not responding to me. Next, we'd have response bias. If I'm like, hi, I'm calling about Knoxville roads, what do you think of them? And they're like, they're great, because they're like, who is this calling me? And they don't even know, what do I mean by what do you think of the roads? Do you like them? Maybe I'm trying to see, like, do you ever encounter potholes on the road? And then we come back and we say, oh, look, our roads are excellent, because we just asked people, what do you think of the roads? So there might be bias in the response, and that's response bias, is if there's an actual bias in the response they tell us. The last sort of bias would be under coverage. So under coverage would be something like if I just called, let's say, I was like, oh, we've got this list of numbers we can call, and it's just like people over 60, because they love responding to surveys. So all these people over 60 will take our survey, and we can get a hold of them and fill out our survey. Sounds a little bit like convenience there, but if you notice, since it's just people over 60, I'm undercovering all the age groups of Knoxville. So we would undercover people of different age groups. So it'd be under coverage bias, maybe a little bit of convenience too, because I'm like, hey, I've got this list of people I can easily get a hold of. But also the reason that it's under coverage is because you could say we didn't get enough of each age group. So I think that talks about most of them, if not all of the different biases, with a quick example right there. I don't think we'll be doing a review tomorrow. I'll be running around all day tomorrow. I'm glad you guys thought this was helpful. Any last minute questions for all of us? Any last minute questions? Any last minute questions? Thank you to the pirates in the chat. Thank you to my other mods. Oh, I'll be running across campus, I'm sure. Thank you guys very much. And I hope you guys do well tomorrow. Email me those questions if you got them. Good night, everyone. We are stopping stream.